story ends happily, I guess, which he says like, okay, fine, go home. You're fine. You'll find your daughter well, right? And that's the way that this particular story ends in the Bible. But still, kind of shitty for him to be like, look, you're not Jewish. I'm not going to help you, right? Like helping you would be like taking meat from my children and casting it to the dogs, which I'm not going to do, right? Like, yeah, this is the guy that everyone decided to like rally behind and be like, wow, this guy is just really great, like accepting of everyone, loving, like, well, not really. Like, I guess if you cherry pick certain verses and read them out of context, like, yeah, he seems pretty nice, right? But if you actually read the whole thing, like, he's kind of a douche. So,
Jesus.
all right. So that has nothing to do with data science, but
Yeah, that's too deep.
So loops. So loops exist in the R language because sometimes, despite our best efforts, we just kind of can't really program without them. However, it should be kind of pointed out or noted that because of the functional and implicit nature of R, it's almost always the case that if you're writing a for loop, you're doing it wrong. That you're not really writing in the R style of doing things. So actually, maybe we ought to do this here, because this ends up kind of coming into play here. Right, so let's, I guess, look at the syntax for this. So you have for loops. So this is done with for, and this actually, control flow, here we go. Oh, I thought it was going to give us like a, oh, it is, yeah, nice. So this tells us, again, we want some index variable in some vector, and then we actually can go ahead and use these open and close brackets to define what's in our for loop. So this is actually necessary in R because you guys maybe remember in Python we just indented, right? And this actually means something to Python. Python actually cares about and is aware of white space. So this actually allows us to define like what's in a loop or what's in a function or whatever without having to do all these like open and close brackets. R actually in no way pays attention to white space, which in some ways is good because it kind of means we're free to do with it what we want, to basically make our code as readable to us and other humans as possible, right? We can make our code actually look quite nice where R doesn't care about white space, but the kind of maybe the downside and what people who are big fans of Python would tell you is that having your language be aware of white space means that you don't actually have to have these like open and closed brackets that show you like where this context begins and ends, right? So in R we actually do need this sometimes. Well, most of the time. So basically, let's see. So let's make some vector. It's hard for me to even come up with like a case for where you do a loop in R, but still, we'll just come up with something. Oops. Or, I don't know. Let's do that sort of thing. Okay. So again, we can make our index variable whatever we want. Now, if the thing that we're going to do in this for loop actually just only takes up one line, then we actually can just put it all on the line next to our for loop, and this will run just fine. Okay, so in this way, actually, I think our syntax can also be quite slick, because you can fit all this stuff on a single line. If, however, we're going to do more than one thing, right? Then that's when we actually need this open and closed curly brackets here to actually show, like, yeah, all this stuff that's happening is in this for loop. Okay? So, print like, right, so we actually now have like multiple lines of code that we're executing within each iteration. Right? And so we actually need to have this context here, right? These open and close brackets that show, like, this is all the stuff that's in this for loop. Okay? So something to actually show you guys that is another case where, like, R can screw you up without you knowing that it's happening. So in other languages, like C, this is very common. We actually loop through, say, like indices instead of the thing directly, right? So we actually can just get elements directly out of X in R. But in other languages, if you're used to other languages, you might see stuff like this, right? Where it's like 1 to the length of X, and then you know, what you're doing in here actually has to do with like the indices, right? Something like this. The reason why you wouldn't just do this in R, like, you actually should never ever write a for loop this way in R. The reason why is because it actually could be the case that whatever calculations or filtering or whatever it is that you end up doing might actually generate a vector that you're looping through of length 0, right? So if your vector actually has no elements, what do you want this for loop to do? How many iterations do you want it to have?
3.
No. So if your vector, say the vector that we generate, that we end up, you know, so say we have previous code up here somewhere that's going to do some calculations and manipulations and generate some vector x, right? And then we want to loop over x, right? What if our filterings and calculations and all that kind of stuff end up generating nothing, right? They end up generating an x that has no length, right? So it ends up being an empty vector, right? How many times do you want this for loop to run then, if there are no elements in x to loop over? 0. That's right. However, let's see what happens. So let's see. Let's just go vector. Equals 0. So this will actually just create a vector of length 0. Let's see what happens if we write our for loop this way. So let's have a print I. Right, so this should do nothing. And you know what? I'm actually going to also put this in its own thing, just so we can see what happens here. So it didn't run 0 times, it ran twice. Right, and it printed out 1, and it printed out 0. Right, so this is dangerous. We don't want to do this ever. The reason for that is because this thing that actually lets us generate sequences. So here, let's comment this guy out for a second. So we can go like 1 to 10, and this will go ahead and generate a vector that goes 1 to 10, right? Or like 3 to 10 or whatever, right? It'll generate this. Oops. It'll generate this vector. That's also the case, though. Let's say 3 to negative 10. So 10 is less than 3. R is totally fine with that, right? It'll just run backwards. So if you write your for loop like I did here, then you say for I in the vector that we generated, the sequence 1 to the length of x, we're assuming by writing our code this way that x is always going to be not empty, right? This is not always a safe assumption, so you don't want to write your code this way. Okay? So what do you do if it turns out that you actually want to be able to have your loop go over indices or reference indices in your vector? So the way that you do this, that's better, is you use this seek function. That's actually one thing you can do. So let's have a vector v that has the elements a, b, c, right? And then let's just do seek v and see what this does. So this vector abc, when we fed this to seek or sequence, generated this sequence 1, 2, 3. Right? It basically kind of like enumerated or gave us the indices of this vector. So let's look at this a little more closely. And we'll see that actually, if we want to be really specific, there's actually a slightly different function we're going to want to use. So let's see. Arguments, yeah. So this takes arguments passed to or from methods, which is pretty vague. So we have the from, to, and by, which we already knew about, right? You guys recall actually covering this function, generate sequences. There's also this length out. So if you don't necessarily know, like, you know, go from like 1 to 10 by 3s, right? Maybe you know that you want a vector that goes from 1 to 10, and you know that you need at least like 50 elements in that vector, and you just want them to be like evenly spaced. That's what this length.out is going to do. Or there's this along with. So let's look at the, or along dot with. So take the length from the length of this argument, right? So that actually now means that we're going to generate a vector whose length is the length of this argument. If you want to be a little more clear about what you're doing, because basically this along with is what's used if you only feed it this one element, right? So if you only give it, or sorry, one argument. If you only give it this one argument, that basically gets passed to this along with. If you want to be a little more clear that that's what's going on, you're actually going to use this seek along b. So we're going to generate a sequence along b. And that's going to do the same thing, right? So now the safer way to make sure that this function, or sorry, that this for loop runs the number of times it actually should, right? That it actually does iterate over the elements of x. But we say we still want to do something with indices, right? And not directly with elements of x. In seek or seek along x. Right, now we say print I. We'll see how long or how many times this thing actually does it. Okay, and we'll comment on this other one so that we don't see it. Right, so we can see that it saw this code, but it didn't do anything because it saw that there were no elements in X, so there's nothing to iterate over. So this is the safer way that you actually should be doing for loops if you ever do them in R. Okay? All right. There are also...
Can you make that comment somewhere just in front? The safer way of running.
So this is safer. So we'll say, like, I don't know, what if... okay. So let's have a little subsection here, though, for while loops. So just like in Python, we use for loops if we actually have like a specific list or a specific iterable that we know we're going to iterate over, right? Or, you know, we know that we actually know exactly the number of times we're going to run our iterations, right? If we don't know, then we're going to be using while loops. And this works in exactly the same way as with Python. So you do while, and then you give it some condition, right, that evaluates the true or false. And then, you know, stuff you want it to do while that condition is true in here. So, and then this also has the break. Oh, maybe it doesn't continue anymore. Or maybe I'm just confusing it with, yeah, I'm probably just confusing that with Python. So for sure, though, it does have this break keyword, which will do exactly what it did in Python. It actually just breaks out of your loop.
So
Okay.
we need to do a condition before the loop. So when we
You
reach,
can. So, you know, you can kind of do something like, you know, I equals 0, and then you can say like while I is, you know, less than 10, do stuff. Again, you have to make sure that you,
add,
yeah, that you increment I, or else this statement's always going to be true, or this condition is always going to be true, and it's going to just run for forever. Right, so you can do this. Right, that works out just fine. The other thing you can do, again, where we have this break statement, is we can actually say while true, oops, right, which is always true. And then we can, I don't know, do other stuff. We can say print I, oh, thank you R for your help. So we can say print I equals I plus 1. And then we can say, which again, we're kind of getting ahead of ourselves because we don't have this control structure yet, but if, you know, I is, just to make sure we catch everything, greater than or equal to 10, then break out of the loop. So, there we go. Oh, and what is wrong with me? So you actually can assign stuff using this equals, but you should like never do it. So we got thinking about Python stuff. We got doing it the wrong way. So R will allow you to do that, which is also kind of ridiculous that R even has like 2 different syntaxes for variable assignment. But yeah, you should only use this. The equals is reserved for like things in functions, right? So like argument assignment within functions and that kind of stuff. But yeah, that's the only time you should use it. Okay, so yeah, let's go ahead and run this guy. Right, so we can see that it went ahead and just ran our loop. Or, you know, ran this and then ran this. Right, so both of these approaches work. Okay? But here's kind of why we don't really need to do for loops in R, is because all these functions are actually vectorized. Right, they're actually made to be applied over a vector element-wise. Right, which is kind of the point of a lot of loops. Right, it's kind of the point of why you would write a loop most of the time.
can I ask something?
What's up?
There's no the repeat until loop.
There's no what?
Repeat until in R.
There actually is, but it's not really used a whole lot. Oops. There we let's just check into what this does. It does exist in the language, but it's been so long since I've used it that I actually just don't remember. Yeah. So let's see. A repeat loop is used to iterate over a block of code multiple number of times. There is no condition check in repeat loop to exit the loop. We must ourselves put a condition explicitly inside the body of the loop and use the break statement to exit the loop. Failing to do so will result in an infinite loop. So this is actually, in a way, kind of like a more dangerous while loop, because this is just, by default, it's just going to like run for forever.
It's
Unless
going
you-
always inside and it breaks
Yeah.
in that deal.
Also, 5 ways to meet your dream girl now, guys.
It's the same as well.
One of them become a data scientist.
Yeah, so that's pretty much the same as this other thing that I showed you guys, this while true. Because true is always true, right? There's like no condition under which true is not true, right? So this repeat is basically this. So yeah. Well, there it is again. They really want you to meet your dream girl. So yeah. So we'll give an example of a repeat loop. Keep wanting to write reappear or reappear loop. All right, so yeah, we can go I is 0, and then just repeat. Again, we don't need any condition whatsoever. So we'll print I becomes I plus 1, and then same thing. So if I is greater than or equal to 10, then break out the loop. Right, so that also worked out the other way. Yeah, honestly, like repeat loops and while loops, like you'll just almost never use them. I just really can't think of too many situations where you use these types of loops. And even for loops, in R, you kind of avoid using these as well, right? Like these, because for one reason, they're not performant in R. These do not run fast. These are about as slow as it gets in the programming world. And you really only do it if there's just like no other way to express the instructions that you want to give your machine.
Okay, what do we need to use if we want to repeat something?
So the thing is, you don't really have to repeat something, right? So like everything in R is a vector, and all the functions in R are vectorized. So these actually, so let's see here. Let's think of some examples of, maybe why. So again, the example that we gave before of, like we want to go through a list in Python, we want to square everything in that list. So we have some vector x, right? That's 1, 2, 3, 4, 5, just like our list in Python. If we want to go through and square every element of this vector, we can. Like R just does it, right? So you don't need to write any for loops to do that. If you want to, let's see. Let me think of some examples here. Maybe some situations where we totally would write a for loop in Python, but we're not going to in R. So let's say string split, right? So we looked at string split before, right? So let's have a character string, looks like this. Actually, a vector of character strings, rather, right? So we've got, like, this is a string. So is this. Me too. Right, so we've got like these different strings in here, right? So if we want to then like go through and split up each of these by let's see, we want to split up each one of these by, I don't know, space, right? Then we can actually say string split s, and the thing we're splitting by is just space. Okay? And then let's look at what s looks like. So you can see that what it did is it went through and to each element, right, applied this, split this up by space. And so now we have a list of vectors where each vector now is the individual word split up by space from the string, right? Normally you would have to write a for loop to do that. R is like, nope, you don't have to do that. I hate for loops. I want to forget that they exist. Not really, it's not that hateful. R is pretty nice. But, you know, it's kind of like, okay, you have a vector, that's fine. I'm going to go ahead and apply this function to every element of your vector one at a time. No problem. Right? So because of this, because all these functions are vectorized, you actually, you know, don't really need to do this. Or, let's see, here's another example. So let's do x and y is, I don't know, some other one. Right? That's the same length as y. Okay? So we can do stuff in Python like, you know, just take the mean, right, or take the sum of a list, you know, and we can do those things here. And we can also do things like the max, right? So we can check what's the max of x, we can check what's the max of y, and we can actually even check to see, you know, like, oops, is the max in x bigger than the max in y, right? Like these are all things we ought to be able to do in Python without for loops, right? So again, oops. What's the big deal here? Oh, I need to run this other thing that has y defined. So how would you handle this in Python though, if I actually wanted you to go through everything in x and everything in y and do an element-wise comparison to see is the ith element of x bigger than the ith element of y? Right? Like that's a thing, right? Like you got to do a for loop for that. However, in R, there's this actually really great function called pmax. We can just give it x and y. So now if we look at the result of Pmax, this actually just went ahead and returned the max out of the first component in x and y, first component in x, the second, the third, the fourth, and so on. So this actually went through element by element and picked the biggest one out of the two vectors, right? So to do that in Python, you for sure would have to write a for loop, right? That says go through, I want you to make another list, right? So I've got these two lists. I want you to go through them, compare them, and I want you to make another list that, like, the ith element of this new list is the bigger of the two, like, you know, in those lists, right? For sure, you would have to write a for loop to do that in Python. R makes this no problem, right? It's a total one-liner because our functions are vectorized in R, right? So because of this, if you find yourself writing for loops in R, you should probably rethink how you're doing it, right? Maybe there is no other way, because sometimes that's the case. Usually it's not. Usually you can just do some function. And this kind of thing is actually very much in line or in keeping with like the functional programming paradigm, right? It's what we call an implicit language, where everything kind of deals with like, you know, and maybe they're called different things, right? So like in R, they're called vectors. Actually in MATLAB, they're also called vectors. In F sharp, they're called sequences, and you know, so like there's always some name for whatever it is, but like basically you have some function that like you just know that this function does whatever it does, like implicitly over each thing in this array that you're giving it element-wise, right? So you don't need to write these for loops because that's handled, right? So because things are vectorized in R, you should just almost never be writing loops. Okay? All right, so now control structures. So these are the if, else. Statements in R. Okay? And this actually also works pretty much just like it does in Python. So we can go x equals, I don't know, some number, right? And so then we go if, in parentheses, we have to give it some condition. And this could be all kinds of stuff, right? So this could be like if x is even, if x is odd, if x is a member of some other set, right, or some other vector, whatever, then do something, right? So if x is less than 2, then, and actually this works like anything else, right? So if the instructions we want to give are actually a thing that would fit on one line, we actually can just kind of put it right here, right? So print, right, x is small, right? We also have this else if, right? We can give it a different condition. So in this one, we already know that x is greater than 2 if we're to this step right here.
Between 2
So we can say if x is, say, less than 8, then print x is medium, else print x is large, right? And this will work. Oh, unexpected else and else, huh? Okay, so we actually may need to, if we're going to do these compounds, because we can actually do, maybe we can do them all in one line. So that might be a thing. Yeah, so if you want to actually combine all of them, then you have to do this on one line. That can look kind of messy, like this example here. So in that case, yeah, we actually do want to do our brackets to kind of show what's going on.
Yeah, it's better like this.
Yeah, I agree.
Indentations.
Actually, usually this like this. Again, R couldn't care less about the indentations, right? I just like it to be more readable. And I think actually for this last one we don't even need it. We could, but let's just see here. Yeah, so. But again, if the thing that we're doing is actually like more than one line long, it's just a good idea to do that. Right, so that's how this works. So either way. So any questions there?
If we want to combine to say between x equal 3 and less than, for example, x lower than 8, we need to put the statement and after and the other statement.
So the reason why this works here, why I don't need these like compounds, is because it checks this one first.
Yeah, I understand.
If this one's false, it checks this one next. If this one's false, it checks, then it just does this one. So if it's checking this one, I already know that x is larger than 2.
Yeah,
Does that make sense?
Okay. In another example.
But in another example, if you'd like to, then you just use the symbols that I taught you guys for the compounds ones. So you can do like if, say x is less than 2 and x is greater than, or no, less than, no, sorry. X is greater than 2 and x is less than 8, right? Then we can do stuff, right? Right, so that's how you do that. And this actually brings me to this other thing here. So you guys may remember when we talked about these like and, or, and so on, that there's actually like a vectorized version and a not vectorized version. Let's talk about that right now, since we're talking about like vectorized stuff. Okay, so we have our vectors x and y here. So what if we do something here, like, so we can say, I don't know, x is greater than 3, right? So let's just see what that gives us. Oh, did I just actually make x 3? I did. Okay, so let's go back up here and let's make x a vector like it's supposed to be for these lines of code. Good, good, good. Right, so this is vectorized here. This gives us a vector that's false, 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 true, true, because x is 1, 2, 3, 4, 5, right? Now if we go y, same thing. Let's just do y is greater than 3. Right, we also get this vectorized output from this. Okay? Now, what if we go x is greater than 3 and y is greater than 3? We still actually get this vectorized output. Right, so this is this vectorized and thing that checks to see for each component, is this true and is this true? Right? Now, what if we do x is greater than 3 and y is greater than 3? Because you guys remember I said that this was the not vectorized version of this. So we can see we only get one thing here. So with these not vectorized versions, all this does is it just checks the first component. That's all it does. Okay. So and then same thing for or. So we have x is greater than 3 or y is greater than 3. And we have x is greater than 3, not vectorized or y is greater than 3. So that's actually the difference between these, is that there's like a vectorized version and a not vectorized version. The not vectorized version assumes that the length of whatever you're comparing should just be 1. So whether you give it something that's like length 1 or not, it's only going to check element 1. Okay? Okay. Trying to think. And yeah, you might actually be thinking to yourself, well, Jeremy, this if-else thing, this is a reason why we might write for loops, right? Because what if we have to do a for loop and then check, like, if this is this, then do one thing, if this is this other thing, then do this other thing, right? Not so. My friends, R has you covered there as well. R actually has this vectorized function called if-else. So this actually takes a conditional vector. What's up?
No, why is not the yellow? That's why. Maybe it's else if.
So the if and else if and all that kind of stuff, these are statements
Yeah.
or keywords. This is a function.
Ah, okay. Okay.
So let's actually write something that's kind of like our Pmax function,
Okay.
right? So we'll say
I thought
if
it was a statement. It was
x is greater than y, then actually maybe just to be safe, if x is greater than or equal to y, to cover all the cases, return x, otherwise return y, right? So let's, and actually I better make our x and y what they used to be. Because again, we're gonna go down here, change what x is. Oops. So x equals this vector, 1, 2, 3, 4, 5, and then y is this vector, 3, 1, 5, 4, 2. Okay. Right, so this actually returned the same thing as Pmax, right? So actually, we didn't even use the Pmax function. We still didn't have to write a for loop. We still actually got to just use this one function to do this, right? So what does this guy do? Actually, does anyone take a guess? Anybody want to venture an explanation? Oh, shit, I didn't bring this. Does anybody want to venture an explanation of the if-else function?
Yeah.
It
I could do
actually it
Go, Felipe.
So what on the border, like just
Yeah, whatever. Just tell us what's done.
so what it's saying is that like do the comparison of the elements, and if x or if the condition is met, return x. If not, return y. So in this case, in the first element, x is smaller than y, so it will return y. And if the x is greater than y, it will return x.
Yep. Although, again, we're referring to actual like elements, though, right? So here's what's that. What's I guess maybe a slightly more precise explanation. I think Felipe is right. I think you've actually got the right idea. So let's just make sure that this is that we're being totally precise in what we're saying. I forgot that's so loud. Why is it so loud? Oh yeah, because my alarm to wake me up in the morning was also quiet, so I turned it. Oh, which also, oh my god, last night I have to start turning my phone to like airplane mode at night because the people on the east coast of the U.S. are 5 hours behind us.
Oh,
And I, again, because I support U.S. consultants as well, I'm actually in many of the like support chats on Skype for U.S. consultants. And so they start messaging each other and calling each other and having all these support calls, and it's like midnight, 1 o'clock for me, and I'm like, shut up!
yeah.
It's so horrible. All right. Yeah, it usually isn't so bad, but like, oh my god, last night was the worst. Then I looked at it when I woke up, and it was that they actually kept getting disconnected and having to call each other back like every 10 minutes. All right, so if else. So if else takes 3 arguments, right? It takes some, logical argument, which is created by some condition. more L-like. And then it takes a, I'm actually going to call these T and F. So these are all vectors of length n, right? They have to be some length. Okay? So what it does is it goes through every element of L. So if, say, L sub I is true, then the output, which let's call this, I don't know, we'll call it X, right? Then X sub I becomes T sub I. So we'll say else if L sub I equals false. Again, I'm kind of doing pseudocode here, so I actually wouldn't need to put this, but then X sub I becomes F sub I, right? So it's like we kind of have this like loop that happens implicitly. But again, it actually goes over these vectors element-wise, right? Because this comparison here, right, this x is greater than or equal to y, because x and y are vectors, like this comparison is a vector, right? But so this is going to create a vector of logicals, true or false. And so in the elements where this evaluates to true, we're going to get those elements of x, and in the elements where that evaluates to false, we're going to get those elements of y, right? So we're going to get exactly the same result as like if in, say, Python or even in R, if we had written this for loop that said like, for, all the elements in X, or in that case, we'd actually probably want like indices, right? Like for I in seek along X. If X sub I is greater than or equal to Y sub I, then give us X sub I, else give us Y sub I, right? Like we could write that for loop, but again, we don't have to because R is super awesome and has all these like has all this vectorized functionality. Okay? So kind of one of the dead giveaways if you've got someone that's like, yeah, I know how to code in R. And then you look at their code and it's like riddled with for loops, like they're not really. Like they maybe understand enough that they can like write functional R code, like R code that doesn't break. Although, as you guys have seen, that's like not that hard. It's actually, you have to be trying pretty hard to get R to break. But that, really, if you have someone who actually is like an R programmer, right, or they actually are like an R developer, R programmer, everything that they write is vectorized like this, right? They don't write stuff the way that you would write Python code. Okay? So yeah, it's one of those important things that you need to make sure you do correctly, because if you, like in an interview or whatever, if you tell them like, oh yeah, I'm an expert at R, or I'm an expert in Python or whatever, then when you show up to actually write code with your team, they will be other people that write code in whatever language it is you're going to use. If your R code looks like Python code, they're going to know that you aren't really an expert level, R programmer, right?
So becoming a good
and vice versa.
becoming a good R programmer also comes down to how many functions you know now.
You do actually have to have a pretty good function vocabulary. That's true. But actually in Python it's kind of that way as well, right? Like how many object classes do you know, and do you understand what all of the methods are for the object classes? Because some of those classes have so many. They have so many methods, right? Like so that's another thing as well. And some of them are actually quite niche, like they're quite specific. Like there's even one in Python that's like a string. So say you've got some string. There's even one that's like is identifier, which basically means like, would this string actually represent like a valid variable name in Python, right? Like super niche application, right? There are some like crazy specific methods in Python. Yeah, so yeah, you're right. It actually does come, and actually there are great apps for that. I think there's one that's actually kind of like the daily R function or something like that. I've seen stuff like that, right, where it's like, you know, R function of the day. And so there are these things where it's almost like, you know, yeah, rfunction.com. Because I don't know, I had an app on my phone before it was stolen in Paris. There's that wave of sadness again. So, oh, that's cool. Survival analysis in R. Survival package. Nice. But yeah, I had an app that was like word of the day, right? Where it's like, here's this vocabulary word, like just a new one every day, so you can gradually increase your vocabulary. Like there are things like that for R, and also for that matter for Python, right? So that you can just like just daily kind of expand your vocabulary, you know, in that thing. Where is it now? Come on. 5 functions I wish I had known 5 years ago. There you go. Oh, there actually is a package.skeleton. See, so I didn't even know that. I actually wrote a package skeleton function for my things that actually creates like a. Oh no, that's true. I didn't know about package.skeleton. This is a project skeleton. So I actually have a project skeleton and a report skeleton function. But yeah. So there's a by, which actually looks an awful lot like apply. Yeah, apply a function across a subset of data where the subsets are defined by the indices argument. That's cool. That's super cool. Yeah, so you should all like immediately bookmark this website. This is amazing. Fix allows a function to be edited on the fly. It is a nice tool to make quick changes, perhaps after identifying problems in a function via debug or to insert or remove a call to browser. Yeah, cool. So all kinds of functions. Or 1 R function a day on R bloggers. No, that's always the command line stuff. This doesn't even know.
That for loop that is over there, do you think was that unnecessary?
Probably. Because yeah, it does happen. It does happen that you do need them. Yeah. So anyway, I'll kind of keep looking to find a better one where it's actually just like more like what you think. Oh, there's just kind of a bunch of these on here. Yeah, so there's got to be a way to like subscribe to this, but we'll look at it. Oh, maybe it's like, hey, it heard me. Subscribe to our bloggers. We'll do that later. All right. So now let's get talking about lunch. I forgot that my phone actually went off. I was going to just keep right on going. All right. So let's go ahead and go to lunch. When we get back, we'll go ahead and talk about functions. So on the one hand, we'll talk about how to build our own. And we'll also just talk about some just good, useful, like good to know functions. Fantastic.